Hey everybody, how are we doing? You can hear the music in the background, I'm sure. Happy Sunday, everyone. Julia, Ben, Nikki, William, Jacob, Madison. Who else is here? Lakeisha, good to see you. EA, good to see you. Good to see everybody. We got the Kahoot music in the background. Let's get the Kahoot going. Hey, Elizabeth and Mayan, William. We got points here. Savannah, good to see you. Devin, good to see you. Caitlin, good to see you. Adriana, good to see you. Carly, good to see you. Nicholas, good to see you. Campbell, good to see you. Sin, great to see you. Blake, everybody. Karina, good to see you, everyone. Yes, Kinga, good to see you too. How's everyone doing? Let's get the Kahoot code up here. Let's get the Kahoot code going. The background's already broken. Wait, wrong button. I hit the zoom button. There we go. Oh my gosh, I'm hitting. What is going on here? Did I break my whole thing? Oh, did I make a mistake? The UT Marvel, I have to change this. Oh no. The UT Marvel no longer works. 2 seconds, everybody. Look at that. We can fix it. I'm gonna have to fix that afterwards. Good to see you too, Holt. Oh, you're saying to Ben. Well, good to see you, Holt. Good to see you here. How's everyone doing? Greta, good to see you here. Let's have some people start joining in the Kahoot. I might try to go fix my Stream Deck. Let's see here. Where's Stream Deck at? There's Stream Deck. So why is the UT Marvel on the 80s effect? Why is that? It's the right thing there. It's on Untitled. What is it doing? Test. No. Untitled. How did this... What did I do to my stuff? I got a 500 million things here. DDR background. Here we go. UT Marvel. Okay, we fixed it. Never change what you're doing. If something works, just don't mess with it. Thank you, Kajal, right there. The music's pretty good right here. Awesome, Wombat. You got it. Mountain Zebra is coming for the crown. Over 100 players. We'll get started here in 2 minutes. 2-minute timer. Begin. 2 minutes till we start, everyone. Giving Owl is going to take you down, says Sin right there. Good to see you. Is anyone Cheerful Tiger yet? Oh, Cheerful Tiger, they're saying is going to win. You know what? Here, we're going to throw out. Remember, we always round up for how many points we get. What if when we do the final Kahoot, what if we had like 200-300 people playing? Tell people, be like, hey, it's a good time to review. You can ask your questions. Who's checked out the latest? You can bookmark this, open this in a new window. But the speedrun videos, we put out new speedrun videos this weekend. So I tried to, my fiance was like, is 30 minutes really a speedrun? I was like, well, I covered the material over 3 lectures. Hey, good to see you, Lucine. But check out the speedrun videos. The Kahoots are a must. I totally agree. We got a minute, 17 seconds till Kahoot starts. If we only say the content quiz, would it be enough to make a good... depends. I mean, everyone, depending on where you're at, requires a different amount of studying. So some people just review and do well. You know, I'm gonna do 1 more minute after this. I'm gonna reset the timer. 2 minutes from now. 2 minutes from now. We've got people still joining in. 2 minutes from now. So 2 minutes till we start. 2 minutes, hang in there. 2 minutes, we'll be starting. We'll be reviewing. Has anyone watched the speedrun yet? Did they help? I hope they help. There's the speedruns again. Check them out later. They're in a playlist on the channel. But check out the speedruns. Good stuff right there. We got a minute and 40 seconds till we start. Ask anything. You're anxious, Maddie? You got this. It's all about review. It's all about practice. Number one thing. Here's what we saw. Don't worry too much. Here's the biggest thing. Carly, thank you so much. What is the biggest thing we learned from analyzing the data on why people do well on the test? So tell this to everybody, whether you're in our section or not. What is the number one thing to doing well on the test that we saw? Now, this will not ensure you do well. Oh, thank you so much, Ella. We did it together. We worked on it. Show up. Hashtag show up. Taking notes. Showing up. Doing the work. Kyle. I do have a favorite class. They're all of them. They're all of them. It's like saying you have a favorite kid. No, I have no favorite kids. I have all favorite classes. And I want all of them to do great. Kyle right there, Brian's favorite class. Oh, Alex is like, what's Brian's favorite class? Just thought it, Kinga, I just thought I'd pop in and say I have, oh, sorry to hear that. I'm sorry to hear that. I hope you're doing well. Liar, Brian. For your nervous too, I've got all, yeah, it's, the more you practice, the less nervous you'll get. We got 30 seconds to Kahoot. So 30 seconds. Feel better. We don't want anyone sick. We want everyone doing splendidly. Glad to hear you're doing all right. Do well with that. If we have some extra time, will the Kahoots on the 201 homepage help? Yeah, I would say start by hashtag show up, come to class, do the work, and then reviewing is going to pay off more and more and more and more. I'm in 207. Oh, thank you so much, Kaylin. How long does this usually last? A little over an hour, and we're starting in right now. So get ready, everybody. If you haven't clicked in yet, get ready to go. We're going to go at the end of this song here. Get ready, it's almost over. It's the best part of the song. There's the hook right here, which just like ends. Here we go. Starting in 3, 2, 1. Here we go. Let's do it. Okay, let's go to the main screen. I see those numbers start to jump up, and I'm like, okay, wait. So we're starting with probability. Here we go. 2 events that can be easily added together must be what? So this is a rule right here, a rule you should know. When 2 events are this, they can be easily added together. Now, in truth, there is a way to add together events that are not this. We don't go into this, but this is the easiest way to add together 2 events. They must be this. And for the life of me, I hope I selected both answers, because there are 2 answers that are correct here that mean the exact same thing. There's 2 answers that are kind of opposite of each other, and they're not the right answer. So the 2 answers that are correct that mean the exact same thing, I'm not blocking either of them. They are disjoint and mutually exclusive. And oh my gosh, I'm so scared right here. Okay, so do I have that picture? Oh man, I might need to go grab that picture. I'm going to grab this picture during the next question. Let's slow down because we need to pause right here. What we have, and I think I really need to go grab that picture. Let's hop to space. Do not leave right now. Do not leave. We're hopping to space. Brian's grabbing a picture right now. He needs to grab this picture. 2 seconds, because this needs to be seen. What does it mean for an event to be disjoint? What does it mean for an event to be disjoint? So what does it mean when events are disjoint? So I'm going and grabbing a picture right now to help out with this. They'll show the code here in 2 seconds again. What does it mean for events to be disjoint? And so this will help right here. Okay, let's hop over to here, and this is great. Okay, good. Let's hop to the main screen. When 2 events are disjoint, it means if one happens, the other cannot happen. So take a screenshot of this table. I wanted to show you this table. I didn't want to draw it. My handwriting's horrible. We all have learned that very much. But right here, you'll see that when you can add together 2 events, they are disjoint, and that's the same word as mutually exclusive. So when you think about 2 events that are disjoint, think about this right here. Like here's disjoint, here's jointed. So if events are jointed, it means that both A and B can happen. I think you should be able to rejoin. You can rejoin right there. Does everyone see that when we have 2 events that are jointed, they would have in a time that they would both occur, as in like we have 2 events right here, and this is events that are what? Disjoint or not disjoint? You have here event A and you have here event B. Are these events disjoint or not disjoint? Oh yeah, here I'm going to go back to in 2 seconds. Are these disjoint or not disjoint events? So this right here, are these disjoint or not disjoint? These are not disjoint. So this means like if you're thinking about, and we'll go back to start in 2 seconds here. If you think about getting a dog or a cat, so if we say like you can get a dog or a cat, what does this shaded area represent right here? That they're what? They're both occurring. So this is not disjoint. If they were disjoint, what would that mean about getting a dog and a cat? You can get a what or a what, but you can't what. So if we think about disjoint events right here, because this is disjoint, which is the same thing as mutually exclusive, you can get a dog or a cat, but you can't get both. As soon as you say yes to dog, you can't get cat. So when we talk about disjoint events, they are also mutually exclusive, and disjoint events are things that we can all get out of the way here of this. Disjoint events are things that we can add together. So disjoint right here, to add together 2 things, they need to be disjoint, and we use the word or. Stay tuned for this right here. I'm not saying that's going to be the next question, but stay tuned. So does this make sense? And take a screenshot of this, screenshot it or write it down, and this video is recorded. So remember, when 2 events are disjoint, which means they can't happen at the same time, you can easily add them together. Let's find out who's winning right here. It's going to be a close game. It's going to be a crazy game. Let's find out who's winning. Agile Rooster. Oof, look at that. Ties right there. Great job, everybody. It's going to be a crazy game. Hopefully you took notes, because the next question's going to be along the same lines. 2 events that have no influence on the probability of each other are what? 2 events that have no influence on the probability of each other. What do you mean by they can be added together? We can just mathematically add them together, Elish. We can mathematically add them together. Like we can just say this or this and add them together mathematically because they're disjoint. But if two events do not influence each other, they're said to be what of each other? Like the probability of it raining and the probability of the Patriots winning. Now, maybe if it's raining where the Patriots are, that would change it. But if it's raining in Knoxville, that would be independent of the Patriots winning. So I think a lot of times people get disjoint and independent confused because you know what's interesting? Here's a note, and this is on the speed runs. If things are disjoint, like let's say we take the dog and the cat example. In this example, are these dependent or independent events? This is a great note to take right here. This is on the review sheet and it does sometimes appear on the test. Right here, these are disjoint events where you can only get a dog or you can only get a cat. Is this dependent or independent events? Are disjoint events dependent or independent? So we got a lot of... Lauren is like, dependent, disjoint things are dependent, and that is very true. Dependent because if you get one, you can't get the other. Michaela, great explanation right there, and that's the kind of answers, that's like the explanations we're looking for. And it's in the speedrun video too. I talk about like examples like this, where if someone gets a dog, you know they can't get a cat. So getting a cat is dependent on getting a dog. Now, a question that goes back to the previous one, if getting the probability of a dog is 70% and getting the probability of a cat is 30%, what is the probability you get a dog or a cat? These are disjoint events. So what is the probability you get a dog or a cat? And there's using the words that we're talking about how to add things together that are disjoint. The probability of a dog or a cat is thus 100%. There's a speed run for every chapter now. Just got them done today. Woo! Got them done. So 100%. And that's when you can add together things that are disjoint. Now, here's a trick question. Hint for the question. What's the probability of getting a dog and a cat? Hint, these are not independent. And we know that you can't get both. So this is a trick question now. So, and there is no non-option on this, but that could be, Alex. Great question. And Parker, you are correct. And so it wouldn't be 21% because they are disjoint and thus they do not meet the role of independence. Exactly, Lauren. You cannot multiply this, so you can't get a dog and a cat because as soon as you get a dog, you can't get a cat according to the rules of this right here. So be very careful. Read the questions carefully. We've already hit upon some trick questions and really great stuff. Remember, this is recorded, and let's see who's going to win. Bronze Pony and Lucky Rabbit. I mean, how can you beat a Lucky Rabbit? I mean, they're their own luck. So Lucky Rabbit, you got my vote of confidence. Let's see who's going to win. To multiply the probability of A and B, the two events must be what? This is a review question now. This is great. And so, Alex, we couldn't multiply them together because they do not meet this rule. This is great right here. To multiply two events, Alex, great comment right there. We can't multiply them together because they do not meet this rule. For two things to be multiplied together, if you're doing proper probabilities, two things that are multiplied together just by 0.7 times 0.3, we must know that those two things are, and here we go, independent. And so make sure to have this. Make sure to have this in your notes. We have the sheet right here. I thought I could exit the full screen. Oh, there we go. Exit full screen. Make sure to have this in the notes right here. When you are multiplying two things together, the math where you multiply, we can, as long as they meet what condition? Everyone put in the chat, when can we multiply two things together? When? And so this is huge. You should know, like, we should practice this, and then we can know this for the test. We can multiply two things together when they are what? Which is the answer to the question. We can multiply two things together when they are independent. That's key right there. So when you're thinking of this dog and cat example, these are not independent. Does that make sense to everybody? You cannot multiply these two together because they're not independent, because if somebody gets a dog, they can't get a cat. Does that make sense? This is a trick question version. But let's change the question totally different. People with fun parents, random person with fun parents has a probability of getting a dog of 90%. Not fun parents. Not fun parents have a probability of only getting a dog chance of 10%. So the probability that fun parents get a dog and the probability of not fun parents, don't worry, I don't know. I like dogs. So there you go. And so even some fun parents don't get dogs, and some not fun parents get dogs. What is the probability that one parent, what is the probability that, oh, but you see, what if it's like one family? Oh, that's a ridiculous example. Let's do this example. Okay, let's say we have two football teams. I used this one during the speedrun video today. So this is you'll get a sneak peek at the speedrun video. We have the probability team 1 wins tonight and the probability team 2 wins tonight. What do you have to assume about these two teams right here to multiply their probabilities? So to say what's the probability team 1 wins and probability team 2 wins? I don't know. Hopefully, I don't know. At this point, I don't want to be a parent, but maybe who knows? What do you have to assume to multiply these probabilities? Devin, you put it perfectly. If they're playing each other, that would be very dependent, because then you would know, well, they both can't win. Because think about that. If they're playing each other, what's the probability both team wins? It would be 0, because you can't say the probability team 1 wins and the probability team 2 wins if they're playing each other. So let's say this is, and then you have to be like, okay, it's not a playoff game where all of a sudden it would be decided, like one of those games where they have to win if another team wins. Let's just say they're independent. One team winning will not influence the other team winning. So what is the probability that both teams win tonight? What is the probability that both teams win tonight? Who here can figure it out in the chat? We have the probability that team 1 wins and the probability that team 2 wins. So probability team 1 wins and the probability that team 2 wins. And so given that they are independent, which we are assuming they are, it would be the following right here. Does that make sense to everybody? It would be 0.28. So we're just multiplying the two probabilities because we have assumed that they're what of each other. We have assumed that each of these teams winning is independent of the other team winning. So what does that mean that they're independent? Knowing team 1 won does what? If you know team 1 won their game, what does that do for team 2 winning? Like if they are independent, you know team 1 won. What does that do since they are independent? I know team 1 won. I'm just pretending. I know that team 1 won. Just pretending. Doesn't tell you anything. That's what independent means. And Alex, you're right. It will not influence the other team winning or losing in any way. So if you know that team 1 won, it tells you nothing about team 2 winning. There we go. That's what independent means. And that's what we have to multiply the two things together. Let's hop back over to here. I'm losing my spot. Let's do this. Who's in the lead? Rabbit, you still there? Rabbit, no. Don't go away, Rabbit. We need you. We need you to win. Let's see this. Golden Turtle, you're cool now. I like you, Golden Turtle. Let's do this. Next question. The probability of a gross jelly bean is 0.25. If you eat 3 jelly beans, what's the probability they're all good? So I'm going to explain this to you. Don't click too quickly. Let's figure out the probability of a good jelly bean. So a jelly bean is either gross or good, and the probability of gross is 0.25. So the probability of good, not gross, is 0.75. So think about a big bag of jelly beans. You shake it up, and you grab 3 jelly beans. Do the jelly beans now care about what the jelly beans are? No, they're independent of each other. So your first jelly bean is good, and your second jelly bean is good, and your third jelly bean is good. So when you think about this, you're doing what with those 3 events? You're multiplying. When I say the word and, you should think first jelly bean is good, and multiply. Second jelly bean is good, and third jelly bean is good, multiply the 3 events together. So what are we doing? We're taking the probability of a good jelly bean and saying it happens 3 times in a row. And a key assumption for this problem is that we're assuming each jelly bean is independent of the next jelly bean we eat, meaning that eating a good jelly bean would not influence the next jelly bean. And if it's a big enough bag of jelly beans, they're not going to influence. But remember, that's the gross jelly bean. So you're really close, Alex. You're really close. That'd be the probability. Well, we wouldn't multiply it by 3. So we want the probability of a good jelly bean and a good jelly bean and a good jelly bean. Put it in the chat. You're close. Everyone's close. Yes, Liam, you are correct. So exactly. There we go. And so you would cube it. Great job. Now, here's a good thing to remember. If ever you do something like, let's say you take 0.75 and times it by 3, what instantaneously tells you that this is wrong? So what about this right here would be like, I don't know about that answer. Like, why would you be like, I'm not going to use that? So this is a good catch. If you do 0.75, you're like, oh, that's the probability of a good jelly bean. I multiply that by 3, more than 1. And so hopefully, like, These are just things we should see and practice and be like, wait a minute, that's more than one. So we have the probability of a good jelly bean and a good jelly bean and a good jelly bean. And there is the probability right there. So does this all make sense? The next problem is a really difficult one. So get ready. Is everyone good with this? So is the probability of a good jelly bean and multiply a good jelly bean and multiply a good jelly bean. So 3 good jelly beans in a row. And they were independent is what we assumed. Get ready for one of those at least one problems. Who's going to win? Ooh, clever lemur. This is a tight leaderboard. Let's find out who's going to win with this next problem. It's an at least one problem. With the probability of getting a multiple choice question correct, 80%. With 5 questions, what's the probability you get at least one wrong? So there's 2 things that can occur. You could get every single question correct. Oof, this music is terrifying. You could get every question correct, or you could get at least one wrong. So think about that. You could take the test, get them all correct, or you could get at least one wrong. And I'll write this down here in a moment. But does that make sense to everybody? You could take the test, get every question correct, or you could get at least one wrong. You could get 2 wrong, 3 wrong, 4 wrong, 5 wrong, or 6 wrong. So when you think about this and this have to add up to 1. What am I talking about? You either get them all correct or add together at least one wrong. And that's everything that could occur. So we want to look at everything but getting them all correct. So what's the probability of getting them all correct? Because it's going to be everything but getting them all correct is getting at least one wrong. So what's the probability of getting them all correct? Does anyone know in the chat? You'd have to get the first right and the second right and the third right and the fourth right and the fifth right like we just did before. So what's the probability of getting the first and the second and the third and the fourth and the fifth right? That'd be the probability of getting them all right is 0.8 to the fifth. Nice job, Ryan, right there. So that's the probability of getting them all right. Now we want to find the probability of getting at least one wrong. So now we don't want to look at the probability of getting them all right. We want to find the probability of getting at least one wrong. And we do 1 minus. Then you got it. The music stopped. So the first one right there, the top answer, I believe, is 0.8 to the fifth. Let's review this. This is one of the toughest problems on this Quizlet right now. Like this is, not Quizlet, this is Kahoot, playing Kahoot. So when you take this test, you will either get 0 wrong or at least 1 wrong. So would you agree that we can call this X plus Y? Like, who agrees with me on this? You will either get 0 questions wrong, or at least 1 wrong. Like, this is how many you get wrong on a multiple choice test. Does this make sense what I've drawn right here? Does that make sense that you either get 0 questions wrong or you get at least 1 wrong? Like, does that, the way I've represented it there, makes sense? I'm adding these two together to say you either get 0 wrong or at least 1 wrong. Great job, Devin. And so now what does this equal to when we add them? Hint, this is another rule of probability. This is the set of everything that can occur. So we have 2 disjoint events right here. Everything that can occur, you either get 0 wrong or you get 1 or more wrong. So this is just how many questions you get wrong. You look at the test, you're like, oh, I got 2 wrong. So you would have landed right here. So you either land on this side of the equation. I hate it when it does that. You either land on this side of the equation or you land on the other side. So what would this equal to if we add these 2 together? If we add these 2 together, it's going to equal 1. So how about we just do y equals 1 minus x? Because we're interested in that side of getting at least 1 wrong. We're interested in getting at least 1 wrong. I hate when it does that. It's always going to do that to me. Well, that's weird. So we're interested in the side of getting at least 1 wrong. So now we just need to figure out the probability of x right here. X is you get every question correct. So since x is you get every question correct, we have to say you get the first correct and you get the next one correct, and you keep getting every question correct. And we're assuming that each question you get correct is what of each question. To do this right here, which just turns into 0.8 to the 5th power, we are assuming that each multiple choice question is what of the previous question that you took. We are assuming that they are independent because we're multiplying them. We're saying you get the first correct and you get the second and the third and the fourth. And when you read this, read it this way. Everything but getting them all correct. Everything but getting them all correct, which is going to give you at least 1 wrong. So you are solving for the probability of at least one question wrong. These are the toughest, and I do 2 examples of this on the speed runs. So I'm going to throw it here in the chat. Check out those speed runs later. And great job if you got one. This question, this is the toughest questions we generally have on this section of the material. Look at that leaderboard just shake up right there. Let's find out who's going to win with the next one. Thank you so much, Kiana. It's practice. It's practice. You did that right there. Great job, Kiana. Which of the following is a rule of probability? So which of these is a rule of probability? We've talked about some tonight. Hint. We got some regression rules on here. Hopefully there's some free points right here. Rules of probability are the rule that's on the screen. The set of all probabilities are equal to 1. The complement rule, 1 minus an event, is the probability of the not the event. The multiplication rule, the addition rule, and the rule that's on the screen. So rule number 2, you have to know the numbers to them, but the set of all probabilities add up to 1. Complement rule, 1 minus an event, is the complement of it, and the probability that probabilities are between 0 and 1. You do not need to know these rules anymore. But here is the rule that all probabilities are contained between 0 and 1. I think we're about to switch topics now. Let's find out the leaderboard. This is a tight game, everybody. And thank you so much, everyone, for playing. Never get QQ straight enough. No, outlier spot doesn't thicken. I agree. Let's see what the next question is here. Next question. A researcher selects the first 20 roads not inside their house. What kind of sampling are they doing? They walk out the door. Are we fine? Is the stream still going? Might have a quick buffer. Sorry, everybody. Should not have hit enter when we were buffering. I didn't know. The first 20 roads next to their house. The first 20 roads. Hopefully we're not buffering for too long. It's good. We're good. It did a little. Sometimes we hit a little buffer. The first 20 roads. Nice job. Sometimes when we get thank you so much, Kayla, and everybody. Do tell me if there's buffers, especially if we're between. I hit it like out of wait 10 seconds. I'm very sorry. Convenience sampling is when you talk to the first 10 people in line. You talk to the first so many people who are closest to you. You put it on Facebook. You can sometimes see some voluntary bias with convenience, but does everyone have a good understanding what convenience bias is? That oftentimes we say we select the first 20 or we put it online. This is a biased form of sampling. It is not good. Convenience sampling is not something we want to do. So get ready for some more forms of sampling, and please ask questions if you have them. We've got a bunch more questions, so I'm going a little quickly, but pause if you have questions and say hey, Brian, I don't understand that, or can you go into greater detail? But when we get that % right, I don't give as much details. Let's find out who the winner is. Will it be 40 questions again? About similar. Most of the tests are pretty much similar, so pretty similar to last test. And remember, Canvas content and these Kahoots are great practice. Agile Rooster in the lead. You never know who's going to win. Let's find out with the next question. Leave a there. A researcher selects every 5th road, technically from a random starting point. So this is when you select every kth element. So pick a random starting point and then select every kth element. Look at all those answers rolling in. People know this one, I'm hoping. So the steps are 1, pick a random starting point, and then 2, select every kth element. So you do pick a random starting point. That's not on here. It's just, there's a lot, I don't know. There'll be a lot more to write. And you only give a character limit on these. Some of them max out. Systematic. We're doing excellent. People know what systematic is. Make sure to use Quizlets for this or note cards. Amazing work. Next question. It's about to get a little more difficult. Get ready. I think next one's easy. We got the next. Wow. Creative Shark. I like that name. And Helpful Jaguar. This is crazy that we got a 300-point lead right here, or 250. This is a close game. All it takes is Agile Rooster missing 1, and it's really locked up. Time frame for the exam is 6 p.m. to 11 p.m. Make sure to fill out the conflict form if you have a conflict. If you have a conflict, make sure to let me know. Let's find out who's going to win here with the next question. A researcher lists all roads and randomizes the order, then selects the first 50. So they are selecting the first 50 of a randomized list. We've put this on the test before, and there's a mistake that happens. So think first they randomize all the roads. Then they select all the first 50. So there's something people usually see, and they're like, aha, Brian was just telling me this. He said it. I've literally gotten emails like, but you said this. But the first part of it is that they are randomizing it. We caught some people. Definitely. Oh, no one put convenience? Oh. So when, that's all right. Oh, well, 3 people. That's all right. Thank you for putting convenience. There we go. So when you do a simple random sample, what is the first step in simple random sample? Take these down right now. First step in simple random sample is to do what? Because we got a little bit mixed up on this one, which is all right. But what is the first step in simple random sample? What is the first step in simple random sample? So you get like everything is given numbers. Exactly. Everything is given numbers. So they have a list of all the roads there and they're going to randomize them. They could have numbers and they're just going to randomize these and then they're going to select the first 50. So if we have a list of roads, we could just consider like rows. Like if you look in an Excel spreadsheet, you could just randomize those and then select the first 50. So you are randomizing them this way by doing this. And we do oftentimes say like we select the first 50 numbers or things like that. So look for, it's not always that way, but this one has tricked many students. That's why I put questions like this on here, but you're going to basically randomly select. Now we're about to do the 2 hardest ones though. So you should have some hints. Hint for everyone listening in. I won't be repeating the ones we've already done. We're about to do the 2 hardest ones. What is the first step in cluster sampling? Things are put randomly into groups, and then we take those groups and do a 1 on those groups. So get ready, because hopefully we do great on the next 2 questions. It's not like a 50-50 split. I'm so scared. What is the step for cluster? Things are put randomly into groups. So be putting this in the chat or be writing it down. For cluster, things are put randomly into groups, and then we randomly select those groups and do a census on those groups. We do a full census on those groups. What is the first step for stratified? What is the first step for stratified? So in the chat right now, what is the first step for stratified? And look for this in the next question. It might be in the next question. I can't remember which one's next. What is the first step in stratified? In stratified, we start by acknowledging a difference. You acknowledge a difference and then sample according to that difference. So have that here and be looking at that with the next 2 questions to see if you get them correct. So stratified, acknowledge a difference between groups, and then sample in accordance to those differences. Cluster, put things into groups randomly, and then take whole groups at once and do a census on those groups. So let's see how we do. Let's look at the leaderboard. Are the steps for each sampling design something we should memorize for the test? I would put them on flashcards, and I'd have a decent understanding of the steps. That'll really help with identifying systematic, stratified, cluster, simple random sample, convenience, all the different types of sampling methods. That'll help right there. It's like putting a student body into grade level. Exactly. Would grade level be clusters or strata? So in the chat right now, would grade levels be better, clusters or strata? Which would you use for that, clusters or strata? So go back to your definitions again. I'm waiting to see more answers, and I want to take care of them. Yes, because you've acknowledged a difference between grade levels. The reason grade levels, because you say, well, aren't they groups? Well, you're not randomly putting them into groups because they're differences. Andrew, you're exactly right. I'm throwing out 100 points. Thank you for coming up with an example there. And then thank you, everybody, for following along and being like, that's strata because there's differences between grade levels. They're not randomly put into the groups. So you would sample in accordance to those differences. So let's see. Oh, we're ready for this, right? We got this, everyone. Let's do this. Let's do this. Let's get ready. Oh my gosh. Just like craziness right there. Like what just happened? What just happened, Agile Rooster? What just happened? What just happened there? Oh my gosh, I'm sorry. Let's continue on. Let's find out who's going to win. Here we go, everyone. Let's go. Next question. A researcher selects their sample based on the percentage of highway, country, and city roads. So what is this? What's going on? It's anyone's game now. Agile Rooster fell from the barn. No, Agile Rooster. It's anyone's game. It's anyone's game. Do we remember the difference between these? Because I've already given hints that we're not doing previous ones. Do you remember the difference between cluster and stratified? So they're selecting their sample based on the percentages of highway, country, and city roads, which sounds like they're acknowledging a difference. It sounds like they are stratifying. No, that's sad music. I gotta learn my buttons. Amazing job. This is great right here, and share Quizlets and stuff like that. More than happy to share Quizlets. I do have the Quizlets posted to the Stat 201 page, but great work. Excellent work. This is stratified because you are acknowledging a difference between the groups. So great job, everybody, right there. Great job. But you can't guess what the next one's going to be. Creative Shark creating their way to the lead right here with Helpful Jaguar right behind. Let's find out who's going to win. Sorry, Liam. I got it right. Went down 3 spots. Kyle, you got this. Kyle, you ready? Here we go, Kyle. Let's do the next question. But be quick. A researcher decides to take 5-mile segments of roads and then sample each 1-mile segment within. So they're taking like a whole bunch at once. So they're like, let's take 5-mile segments and then sample, like do a census on that 5-mile segment. So, you know, like, hey, like we're going to take like a segment with 5 miles, like 5 roads, 5 miles in it. And we're going to do we're doing this sort of analysis. We're taking a whole bunch at one time. Taking a whole bunch, just roads, taking a whole bunch of roads. Keyword census, exactly. Keyword census. And what does the census mean? They're taking data on all of them. So they're doing that right there. Now, what if they took, they went out and took, be very careful. What if they took every 10 miles, they took a 5, or every 100 miles, they took a 5-mile segment? Every 100 miles, they took a 5-mile segment. What kind of sampling method would they be doing then? If every 100 miles, they took a 5-mile segment. So they go across long roads in Tennessee, and every 100 miles, they take a 5-mile segment. You're close, Kiana. You're close. It does have an element of systematic. So they're going to, exactly, Parker, right there. It'd be multi-stage, and you're on a great job. It would be a multi-stage with systematic and cluster. So it's clustered. No, you're fine. This is all practice. Write down the definitions, ask the questions. Great job, everybody. This is practice. You don't want to win the Kahoot. I mean, you want to win the Kahoot. I want to win the Kahoot too. But it's better to not win the Kahoot and ace the test. The more you learn tonight, the better. There's only going to be a few winners, but everyone's a winner right here as we give out some more points for positivity. 100 points right here for everybody. Stay till the end. We always give out some big points at the end. So let's do this. Let's play again. Find out who's in the lead. Creative Shark, we do not know who's going to win. It's anybody's game. The leaderboard's been bouncing around this whole time. Let's find out with the next question. We're about to do some more definitions here. Next question is, the researcher takes too many city roads in their sample. Too many of something would actually cause this bias. It's a little tricky because you're like, too many? How can too many cause this? Well, think what happens if you take too many of something. Like if you go out and you say, I want to go to Krispy Kreme and try their donuts. And you're like, but I'm only going to try Boston Cream donuts. Well, then what have you done to all the other donuts? I mean, Boston Cream's the best, but you should try the other donuts too. I mean, Krispy Kreme's got all the great donuts. Sorry, I miss Krispy Kreme. So if you take too many of something, you would thus undercover. So undercoverage bias is when you have too little of a certain group in your survey. So don't worry, William, you got this. So undercoverage bias is taking too few of a certain bacon donut. Man, Kyle, that sounds awesome. I should learn how to make donuts. I don't know. I just want more time. Time is what I want to do everything, to learn how to edit videos, which hard to do that anyways, but I always want to learn everything. So undercoverage bias is when we have too little of a certain group in our survey. What is non-response bias? Hint for coming up for the future. Non-response bias is when the groups or items that don't respond are different in some way than the things that do respond. So if we call people on the phone and they hang up on us, that's non-response bias. But what if we call people and we say, do you think it's fair that 18-year-olds can get married, but they can't buy alcohol? What kind of bias are we putting in if we have a question like, exactly, Lauren, what kind of question do we have, or what bias are we putting in when we say, do you think it's fair that 18-year-olds can get married, but they can't buy alcohol? Do you think we should lower the drinking age? Response bias. So when the wording of the question or the researcher or somehow influences the response of individuals, that's response bias. Undercoverage bias is when we don't have enough of a certain voice or group in a survey. Like, let's say we want to understand college students, so we go to the University of Tennessee. Now, I'm not saying University of Tennessee is not college students, but what would be the issue with, like, we want to research college students and understand their views on issues. What would be the problem with going to the University of Tennessee, only going to the University of Tennessee? Like, why would that be undercoverage bias? If you said, I want to understand college students, exactly, Ella's getting to it right there, and great job, Crystal, right there. It's only UTK students. So any sort of key characteristics we have that might underrepresent college students as a whole, we would not have a representative survey. You're saying too little, but the question says too many. Exactly. So what if it says the researcher takes too many UTK students? So the researcher takes too many UT students, then they've created an undercoverage of other students from other college. Non-response bias is when the things that don't respond. So maybe we ask a question like, what are your political views? And I say that because usually controversial questions are usually less likely to get people to respond. And maybe people don't want to respond. And the people who don't respond to the question differ in their views than those who do respond. So think of non-response as people literally not responding to your question. Does that make sense right there, Alex? People choosing not to respond differ in their views than those who do respond, and thus we don't get a representative view of the population, because if people don't respond and their views are different, then we don't get responses from them and they can't be in our survey. So great questions and everything right there. So awesome. I think we've got everything. Keep asking questions, especially between questions. Usually when I see a few people miss it, we try to pause here. From a legend pony in fourth. Oh, this is insanity, everybody. This is insanity. This leaderboard, Yellow Dragon out of nowhere, Brave Ferret, Creative Shark, Legend Pony. Let's find out who's going to win. Golden Turtle's back. You got this, Golden Turtle. Make it happen. The researcher is unable to get information from certain roads selected, so they can't get out to these certain roads. They cannot get information, as in these roads right here that they are collecting on. They can't collect info on some roads. They can't get responses from these roads. So that's what I could do for roads, thinking about how we might get this kind of bias right here. If the researcher tries to go out to these roads and is like, well, we just can't collect info on them. We can't get data on these roads. The roads we wanted to look at, but we can't get data on them. And this was the best example I could come up for with non-response. Great job. Great review right there. I want donuts too. Knoxville does have 5 legit donut shops. We used to have Maker's Donuts. I don't know if they're back, but Maker's Donut, if they are back. I literally saw that right as I was leaving, that Krispy Kreme left on this trip. Or maybe I saw that when I was Google Earthing it. That even gets the sad rain. Man, I waited a long time for Krispy Kreme to be like on the strip. And I missed that. Man. Brave Ferret, congratulations. And Creative Shark, this is anyone's game. Anyone's game right here. Let's do this. This is craziness. Here we go. I know. Let's go. The list of roads the researcher has access to sample. What is this? Now, this is not all roads. This is not all roads, and they will not take all roads here. There's more roads that they are interested in, but these are the roads they have listed that they could sample from. So the definition of this is everything the researcher has access to sample from. This is everything the researcher has access to sample from. So the word you're looking for is everything the researcher has access to take their sample from. I'm hoping we see some awesome answers on this. If we get like really good answers, I'm gonna hit the button. I'll take that. That's really good right there. Duck Donuts is pretty good. I like Duck Donuts too. It's good stuff. Oh man, waffle. We used to have a Waffle House. No, we had an IHOP on campus, and it was not the best back in the day. But the list of roads the researcher has access to sample from is the sample frame. So I want everyone to think about this example right here. If you go to the library and you want to talk to students and take samples, what is your sample frame? So here's the example. You go to the library. Oh, this is a great question right here, Pierce. Let's go into this. And Pierce, thank you for asking the question. So if you go to the library and you want to get to know students, like ask them questions to sample, then what would be the sample frame? So you go to the library to talk to students, to understand students. What is the sample frame? Because we're going to differentiate sample frame population right here. Status Do is really good too. You go to the library to talk to students. What is your sample frame? Students in the library. Students in the library. You could say like students in the library at that time. Does that make sense? So why is that your sample frame? Like explain why students in the library, even though you want to understand students, why are students in the library your sample frame? So why are students in the library your sample frame? Why? And can you explain like, what do you mean the students in the library are your sample frame? Because those are the people you could theoretically wait. And what? I was going to say what? Maya's right. Those are the ones you could possibly speak to. Does that make sense? The sample frame is everything you could possibly collect data on. Who is available? Great job, Sarah, right there. So these are the ones you could possibly speak to. Now, what would be your population? Just think in general, you want to talk to students. If you have access to students in the library, you're probably interested in understanding who. So even though this is your population, so your population is probably UTK students, But then your sample frame would be students who are in the library at that time. And maybe someone said, oh, like, so all students would be the population, Pierce. Exactly. Does that make sense? Like, all students is your population. Your sample frame would be the students who were in the library at that time because you had access to sample them. And then the students you speak to or you collect data on, hint for a later question, would be your sample. So if you were in the student union, the sample frame would be the student. Exactly. Students in and around the student union at that time that you could have possibly spoken to would be your sample frame. Does that make sense, Jennifer? And great questions, Pierce, right there. Just feel, especially when we're paused between things, and tag me. I'll see it, and hopefully we'll give some great answers tonight. The sample frame is everything you could have theoretically sampled. You don't actually have to sample it for it to be in the sample frame. Like anyone in the library at that time, you could have theoretically spoken to. If you speak to them and they give you info, they are in your sample. But if you want to understand them, like UTK students, they might not be in the library. You might not have access to talk to them. Let's see how well we have these down. Oh, what is parameter of interest? That is the thing we are interested in understanding about the population. So whatever we want to understand, like maybe we're asking them, like, do you miss spring break? Probably yes. I mean, I'm guessing because I can agree with that. If we ask them, do you miss spring break? That is what we're interested in collecting data on. So the parameter of interest is the characteristic we want to understand about the population. So the parameter of interest is the characteristic we want to understand about the population. Does that make sense right there? Caitlin says, yes, I miss spring break. Put yes in the chat if you miss spring break. And I will assume no if you don't put no. I mean, you don't put yes. Let's do the next question here. Get ready. Rip spring break. This is for spring break right here. Full on sadness for spring break right there. We're back. Let's do this. Let's do the next question. Here we go. Gotta do that joke every Kahoot. My hair is going, what the heck? It's attached to the microphone. The roads that the researcher samples, the ones they actually get data on. This is not a trick question. This is not a trick question. I don't need spring break. I want spring break. And when you know it, I don't want spring break. I need spring break. When you need spring break, that's a responsibility that only an adult of my maturity can understand. Bunnies. If you get that quote, you're probably as old as Brian. It's not about spring break. Yes, good answers right there. We should take the... I'm sorry, we got Friday off, right? So good stuff right there. Great answers. Great work, everybody. The sample is what you actually collect data on. I'm sorry, Kyle. I'll work extra hard for you, Kyle, right there. I'll work extra hard since no spring break. You got it, man. So the researcher, the roads the researcher has data on is going to be that. So we only have one more term right now. So if you're following along, get ready for the next one. Here we go. Everyone checking their points. Brave Ferret. This is a close game, Brave Ferret. This is a close game. It's a close game, everyone. Let's find out who's going to win right here with the next question. The roads the researcher wants to understand. Oh, so this is the roads they want to understand. They're saying, like, we are interested in Tennessee roads. Tennessee Road, Country Road, Take Me Home. Wait, that's West Virginia. We don't want to go there. We want to go to Tennessee. Tennessee Road, Take Me Home. What the roads they want to understand, the Tennessee roads, is going to be the what? The roads they want to understand, the roads they're interested in. Everything they want to understand is their population. Oh, no. Wait. So we tricked people. We didn't mean. So wait. But this is just the roads they want to understand. It's not, how would it be parameter? Because the group they want to understand is the population. Don't worry. The group, like I got it. No. The group they want to understand is the population. They want to understand the roads. Like you want to understand UT students. Does that make sense? Oh, I'm sorry, buddy. When you want to, like if I said the students the researcher wants to understand. Parker's got it right here. Parker, because what they want to understand about the roads will be the what? I've never been happier, King. So wait, let's slow it down right here. You want to understand UT students. So the students the researcher wants to understand is the what? The students the researcher wants to understand would be the what? The students the researcher wants to understand would be the what? So just listen to this question a few times. The students the researcher wants to understand would be their what? The students the researcher wants to understand would be the what? And there will be the population. Does that make sense? The students the researcher wants to understand. How could Brian change the question now to make it a parameter of interest question? This is good review right here. This is great review. The students the researcher wants to understand is the population, because that's the group they want to understand. So the roads they want to understand is the population of roads. How do we change it to a parameter question? Like, change this to a parameter. Something like of interest would be, Leslie, you're on track with that. So population is who you want to understand. Parameter interest is what you want to understand about that group. Exactly, Michaela, right there. Look at Michaela's comment. So the population is the who or what you want to understand, and the parameter is what you want to understand about that group. I know roads are kind of a what thing, like roads are not a who, but what we want to understand about the roads is the parameter. And does that make sense right there? The roads is the group we want to understand. We want to understand these roads, and what do we want to understand about the roads is the parameter of interest, like a characteristic about them. Like what percent of students like donuts? Does that make sense right there? So parameter, basically think about it this way. Parameter is just some sort of quality. Like maybe think about something you'd want to understand about yourself, like how fast you can run a mile, how high you can jump, how tall people are. Think about something you'd want to understand about yourself, and you might say, how fast does the average person run would be a parameter of interest. And then the group would be people. So you might want to understand people, that's the population. So the individuals the researcher wants to understand, that's the population. And then how fast those people run would be the parameter of interest, like a quality. So when you hear parameter of interest, think, what do they want to understand about that group? Is this helping out differentiating these? The parameter of interest is like some quality about the population that we want to understand. I know the roads example is a little bit harder. We had a previous test that did this a long time ago, so this is modeled after an old test. I try to pick the ones. So the parameter is a quality about the population. So populations have parameters. Think of this example. Kaylin, great questions tonight. Thank you, Kaylin. Let's talk about UTK students. There is a parameter that would be in-state students. So the registrar knows what percent of students are in-state. Is that a parameter or a statistic? So when we go over this on the speedrun videos, is the proportion of in-state students for all UTK students that the registrar knows, would that be a parameter for the population? Hint right there, or a statistic about UTK students. So would we say it's a parameter or a statistic? Because the parameter means it's the truth for all. So it would be a parameter. It'd be a parameter since it's for all UTK students. So if we have data on the full population, it'll be a parameter. And then oftentimes we want to call it a parameter of interest. No worries, Ella, no worry. This is practice time. So the parameter is some sort of quality, like what percent of UT students are in state. Does that make sense? Like we want to understand UT students, and maybe the registrar knows the parameter of interest, like which is just a quality, like the proportion or like the average GPA of UT students. And oftentimes we don't have that data, so we have to collect data to understand it because we might not know. We don't always have the registrar for all populations. So really good job. Leaderboard is going crazy. It's anyone's game right now. Let's find out. When do you know if it's a stat? Ooh, that's great. When it has a sample size, Campbell. So whenever we have a sample size, then we're talking statistics. So whenever say we take a sample of this amount, then it's a statistics. Oh, Kyle, why? I'm going to respond to that. That would be amazing, Kyle. They used to do that over there. SSPP, sample statistics, population parameters. Ella, that's worth another 100 points for the chat. Write that down, everyone. SSPP, sample statistics help us understand population parameters. SSPP from the lecture, remember it. So here we go with the next question. Let's do this. The researchers collecting the average amount of potholes per mile. That seems to be what they want to understand. The researcher wants to understand the average amount of potholes per mile. To say on average on Tennessee roads, we see this amount of potholes per mile. That is what they want to understand. It's a quality of the population they need to better understand by collecting samples. They're going to collect a sample from the roads they have access to understand the population. And this is their parameter of interest. I hope this helps differentiate these words, but this is the parameter of interest. Great job. Great responses. Just complete and utter. Exactly. So hopefully, let's see. Leaderboard this is crazy. It's absolutely crazy. Do people feel like they have a better understanding of sample frame, sample, population, parameter, all these words right here? I do go over them during the speed runs. So, you can just play it in the background if you want. That's always a good opportunity. But I'm going to drop the speedrun list here again. Thank you, Crystal. Glad it's helping out. Speedrun playlist, I'll drop it here at the end again. But it's a playlist. If you just like play it in the background, oh no, you're just like, I'm just going to do some work and just listen to this in the background. Sometimes it helps just hear those things in your head or to sit down and take notes. Sitting down and take notes, great thing to do also. So let's do this next question here. Probability of making a shot is 30%. What's the complement? Psh, we got this. Psh, this is easy. As long as Brian didn't mess it up. Oh, God. I reviewed this one before I did it tonight. 100% was probably make a shot. What is the complement? So this goes into some very important stuff here with P and Q. P and Q are complements. So if we have the probability of making a shot is 30%, probably Brian's probability, if not less. Is there a sheet with what these mean? The Quizlets. I think the Quizlets posted. I'm about to have a heart attack if I get it wrong. Like if I get this wrong, I'll be like, no. Clarissa, which sheet are you looking for? I think I have a Quizlet posted. I think it's on the Statistical website. What's up with the screen? Is something going on? What's up with the screen? Everything okay? Looks like 3D without the glasses. Everything okay? Oh, okay. Yeah. Thank you so much. Yes. Thank you so much. Caitlin, make sure to go to the HD button. And so if I'm not in HD, there's a button right here. So YouTube sometimes lowers the quality. And so everyone, if you want, go ahead and click the HD. Thank you so much. That's why we had Mubot put that command in there. So exactly. And don't worry, you probably didn't know this your first time watching, because a lot of people are like, wait, all of a sudden the quality went really bad. So it can look like really kind of odd and grainy, but then you can up the quality to 1080. We're actually using a 4K camera. Thank you, Haslam College of Business. We could maybe one of these days stream in 4K. I don't know if I ever will, but we could have that ability, and everyone just destroyed this question. So I was like, wait a minute. I was like, oh no, what happened? Oh no. Clever lemur, you got this. I like lemurs. They're super cool. Brave ferret, who knows who's going to win. Next question. The law of averages is a fallacy. The truth is what? So the law of averages is something that is not true. So what is the truth right here? The truth is what? If you talk about hands of cards, the cards don't care if you keep losing. So think about it, you keep losing, like these events that happened previously. Like you're like, I'm due for a win. That's the law of averages, which is a fallacy. Fallacy means improper way of thinking. If you keep getting bad hands of cards, it will not influence your next hand of cards for you to win. So what does this mean? I'll be blocking this one if I appear. Exactly, great job. So past events do not influence independent trials. So you could keep losing at cards and you're like, I'm really due for a win. I haven't gotten a good hand of cards in a long time. No, the cards don't care. The cards don't care that you keep losing. That sounds so sad right there. So we'll play our happy. It's a gambler's fallacy. They call it that. Devin, did you hear that in psychology? It's the first time I heard gambler's fallacy in psychology. Got our happy, sad music right now. So gambler's fallacy, yeah, and it's basically law of averages. Like, I'm due for a win, everyone. I'm going to win because, that's what we do. What is the truth right here? The truth is, can I write that down? Sure, let me disappear. So the truth is the law of averages, that in the long run, you'll see the true probability. And what do we call this? That in the long run, you will see the true proportion of something. The probability that in the long run, you will see the true proportion of something, that is called the what? The probability that in the long run, you will see the true probability of an event. In the long run. So the long run probability event, you're welcome, Campbell. The long run probability occurring over time, over many trials, is called the law of what? That if you do something repeated, exactly, Devin, great job right there, the law of large numbers. So, and it's the central limit theorem is going to be the approximation of the normal distribution by meeting the three conditions. Great job right there, Kirk. The central limit theorem is going to be the approximation of the normal distribution by meeting the three conditions, and the normal distribution becomes tighter and more normal, or the distribution. Anyways, that'll be coming up here in a second. The three conditions right there. The law of large numbers states that, think about flipping a coin. If you flip a coin one time, it's either going to be a probability of this of heads or this of heads. It lands heads. Then what % heads have you gotten now? We know it's a fair coin, let's say. So you flip it one time, you get heads. What % of heads do you have right now? And do you think that's true for the coin? So the law of large numbers states in the long run, you will see the true probability of an event. If you flip it one time, you have 100% heads now. But what happens as you keep flipping that coin? Repeated trials. Over repeated trials, the coin's going to start to go towards 50%. But what if that coin flips tails 10 times in a row? What do you think it'll flip next? So the coin just flipped tails 10 times in a row, which is super unlikely. What do you think that coin will flip next? So what's the answer to the coin just flipped tails 10 times in a row? What do you think the coin will flip next? Either or, like, I don't know, it's a 50-50 coin. You're like, but wait, it just flipped tails 10 times in a row. We don't know. They're independent trials. That'd be the law of averages, which is a fallacy or gambler's fallacy to say like, well, it's going to flip this because it's more likely because it just flipped tails. Now, if the coin is a true 50-50 coin, then knowing what it flipped previously will not impact it, and that's the law of averages. Knowing the past coin flips, that it just flipped 10 coin flips, tells us nothing about if it's going to flip tails again. A lot of times people think, well, what's the probability it flips 11 tails in a row? But we're not computing that. We're saying it flipped 10 tails in a row. What's the probability it now flips tails? That doesn't tell you anything. It's 50-50. So that was the law of averages when I did that example, saying like, what's the probability you get an 11th tail flip after 10 tails flips? So that is the law of averages and the law of large numbers. Law of large numbers is the real one. Creative Shark in the lead. Everyone ready for the next question? Good review right there. Good review of some concepts. Get ready. It has a chance of getting, oh yeah, no, ridiculous, right? So is that 0.5 to the 10th power right there? That should be 0.5 to the 10th power. That is insanity right there. Devin, great job. Let's throw out some points here while we look at this next question. We know that 20% of freshmen, we know UT is 20% freshmen. We take 200 students in a sample. What is, well, the answer's on the screen to it, as long as you know notation. We sample 200 students and 30 report being freshmen. What is N? This is a notation quiz. What the heck is N? Well, N means the sample size. So if you know that N is the sample size, what is it going to be? So this one's one of the easier ones. Remember, these questions kind of cycle through. There's a notation quiz right here. You should instantaneously know this one. This is the easiest one. I'll take it. That's some great answers right there. That is the sample size. These questions are about to get a little bit more difficult. And remember, we are narrowing down what the answers are. So we understand that is the sample size. Leaderboard is tight, but all it takes is one wrong answer for someone to jump into the lead. Andrew, I'm so sorry. The way the wording almost tricked me into doing math. I think you won't have to do math for about 2 more questions. So the math won't ever be too complicated on, ooh, grab a calculator. Let's take a 1-minute break right here. Grab a calculator. Let's go 80s mode and just get everyone hyped. We're going into space. We got our 1-minute break right here. We're going 80s mode. We're going full 80s mode. Hacker mode, man. Grab a calculator real quick. You're probably going to need it. We're full 80s mode right now. We go full 80s picture when we do this too. 80s mode. Initiate. Grab a calculator really quick. Full 80s mode right here with Hacker Man. Get ready, everyone. You bet it's synth. Timer's almost up here. Go grab that calculator. 20 seconds left. There won't be a z-score. There will be the standard deviation formula. So that's some hints right there. There will be the standard deviation formula. So there will be the standard deviation formula. P times Q over N square root. P times Q over N square root. P times Q over N square root. And I didn't put confidence intervals on this. And I didn't put decision trees. So it's already a long Kahoot. Got it. Let's go. There's the timer. Let's hop back here to the main screen. Okay. Let's do this. Here we go, everyone. Next question. Let's go. You will need it. Yep, will be supplied for you. We know that 20% of UT's freshmen, we sample 200 students, and 30 report being freshmen. What is P? Be very careful. You do not need a calculator for this one. Someone already clicked, or they're like, I can do that in my head. You don't need a calculator for this one. This is also a notation test. What is the answer? What is P? P is the true proportion. P is the true proportion of the population. 80s spaceman. I like that right there. I like that, PJ. What is the true? Oh, we got some people. So what does P stand for? P stands for the true proportion. We know this. So this means this is the truth for the population. So what if I told you, let's review. I don't know if I put this one on here. What is this in notation? A lot of people answered this. What is this in notation? What is 30 in notation? Like number of successes. So what, but that's, I haven't said what it is. Ah, Devin, you're on the right track. Yes, Devin, that is correct. That would be the sample proportion. And there we go, Jacob, you got it. That is X. So this is X, the number of successes. This is n, the number of trials or samples we have, sample size. And then this is the true proportion. So 30 over 200 will be p hat. So keep that in mind if we ask you what the sample proportion is. So p hat is the sample proportion. Who's in the lead right here? Holy mackerel, total change of leaderboard. This is insanity, everybody. Like, this is a fight for the leaderboard. It's like there's a $50 Amazon gift card on the line. Please email me with the email address you want it sent to. Like, you can email me from your UTK, preferably email me from your UTK so I know it's you, and then say, hey, Brian, send it to this email address, and I'll send it to that email address. Because it looks like tight leaderboard. Here we go. UT is 20% juniors from 80 students, 30 are juniors. Find the mean of the sampling distribution. What is the mean of the sampling distribution? Oh, everyone's like, oh no, how do I do this one? This seems complicated, but it's not. What is the mean? If we know UT is 20% juniors from 80 students, I already given away the answer. If we know UT is 20% juniors and you go out and collect a sample, what would you expect to see in that sample? If UT is 20% juniors and you take a sample, what percent of juniors would you expect to see? If UT is 20% juniors. Oh, we lost a bunch of people. What happened? So what is the formula right here? The formula, let's bring up the word sheet. The formula for this one seems complicated, but I promise it's not. The formula for this one is merely this, and I want you to think about what it means. Mu p hat is equal to p. So what does this mean right here? Mu p hat is equal to p is just saying, if we know the truth, what would we expect to see, like on average? Because that's the mean. Like, what would we expect to see when we take a sample? So if I sample 100 students and we know 20% of UT is juniors, what percent of that 100 students would you expect to be juniors? So I sample 100 students and we know 20% of UT is juniors. What percent would you expect to be? Exactly. If I sample 500 students, what percent would you expect to be juniors? If I sample 500 students, what percent of those 500 students would you expect to be juniors? Notice there's no sample size in this. There's no sample size. It's just like, well, 20% of UT students are juniors and I sample students and I expect 20% to be juniors. Now, what does change right here with the sample size? Oh, I missed you. What does change with the sample size is the standard deviation. The standard deviation for this one is P times Q over N square root. Remember to use this in a moment here. So this is going to change with the sample size, and this is the central limit theorem, that this will become water as the sample size gets larger. As the sample size gets larger, this standard deviation will become water. It'll become smaller, and that's part of the central limit theorem, that the distribution will become more normal and also will become tighter as the standard deviation gets smaller. I mean, that's true. As standard deviation gets smaller, as sample size increases. So the sample size increasing will make a tighter distribution, which is part of the central limit theorem, that the distribution becomes more normal and tighter as the sample size increases. Have those two notes down. I'm going to write them down right here. Central limit theorem. So central limit theorem notes, like two big important concepts. So the two big things we should know right here are, one, the distribution becomes more normal as the sample size increases. Or let's do this. There we go. There we go. So here's the two things you should know for the central limit theorem. The distribution becomes more normal and more tighter, whatever. Grammar. I don't like grammar. So these are the two main things to know, and we see it, one, via the formula, and two, via the conditions, that the distribution is going to become more normal and tighter. So we're going to see some conditions here in a moment, but those are two key notes. Remember, pause the video or take screenshots. Great way. Let's find out who's in the lead. Leaderboard's going to go crazy. Yellow Dragon, Clever Lemur, Helpful Jaguar. Who's going to win? Who's going to win right here? Let's do this. Next question. We know UT is 20% fresh and we sample 200 students. What is P hat? We've got 30 reporting. What is P hat right here? You guys and gals and everyone got this. You got this. What is P hat? P hat is the sample proportion. So just think, what proportion of your sample what proportion of your sample responding? This would be p hat, like p and then hat over it. Maybe Kahoot will accept that now. I should have tried to update this one. Should have tried. Should have. Brian, what's she doing, man? What's she doing? So p hat is the sample proportion found by x over n. A lot of people forget that one. It's just 30 over 200. Oh, this is review. This is review. Let's do a review question right here because we got a few misses. So we go out and talk to 500 UT students and ask them if they would like free cookout. 425 respond that they do. With responding that they do. Okay. Okay, I'll make this super easy. I don't know why that other 100 didn't want free cookout. Identify everything in this problem that currently exists. And this is a bonus problem now from another chapter because I didn't put this chapter in this review, and I'm going to solve this problem for you. So identify everything in this problem right now that exists. There's a third thing we can find. There's actually a fourth thing we can find, and I'll write the last part of this. Construct a 95% confidence interval for the true proportion of students who want free cookout. So what do we have right here? X is 400. That is the amount that responded in the affirmative. We have here this. And so what else do we have? Yep, p hat and q hat, exactly. So then we get x over n is equal to p hat, which is equal to 0.80. I guess we should, here, we'll put it over here. 400 over 500. Please, if I write anything out and you don't know, just let me know. So how do we find, can we find p hat and q? And we have the sample size, exactly. So we don't do many reverse problems, but there's sometimes our algebra problems on there. And great job. How do we find q hat? Here, we're going to play a game right now because some people are probably wondering how we get q hat so easily. Is everyone ready for the p hat and q hat game? You ready? So the p hat and q hat game is going to be this. So 1 minus p, great job. So you ready? And so whenever we have to find p hat or q hat, or we have to find q or p, if p is 0.6, what is q? If p is 0.6, what is q? Great job, Akil and Abby and everyone. If p is 0.6, what is q? So we should know instantaneously how to get. P is 0.6, what is q? And so q hat is the complement of p hat right here. Great question, Caitlin. Does that make sense? So if p is 0.6, q is 0.4. P hat is the sample proportion. So if p hat is 0.7, what is q hat? And Alex, you're exactly right there. So if p hat is 0.7, what is q hat? Great job. No, Caitlin, this is excellent. This is practice. And so yeah, be practicing along, Pearson, everybody. If p hat is 0.7, q hat is 0.3. They're complements here. Great job, Crystal, right there. Their complements is the practice we need. So when we get to the test, we're like, okay, p hat, q hat, got it. Because now what we need to do, and great job, I can't remember who said in the chat, but someone pointed out that this is basically we're going to put the exact z-score of 1.96, and the test would give you that. So now we go down here, and we can solve the confidence interval. The confidence interval is going to be p hat plus or minus z star, which we are choosing it to be 95% confidence, and then we do square root p hat times q hat over n. So right here, do we use 2? We'll use 1.96 on the test and use it for the homeworks too. It's more exact. And if you get something off on the homework, just barely tell me and I'll probably fix it. Like, highly likely I'll fix it. Unless it's really off, then I'll be like, that's pretty far off. I'll be like, that's a little further off than a small error. So here is the interval right here. Now, everything I'm highlighting right now is known as the what? Everything I am highlighting right here as I solve this out mathematically, everything I am highlighting right there is known as the what in a confidence interval. Everything I've highlighted right there is the margin of error. On the exam, we'll use 1.96. So we will tell you, I have not seen that, we've never not said. We always give the z-score, and we say like the z-score for a 95% confidence interval is 1.96, and that's 3.5% right here. So 0.80 plus or minus 0.035. Who can construct this interval right now? Take a moment and try to tell me this interval goes from blank to blank. So this interval, And we can go over how to find the margin of error. Ooh, I got a really good example for that, Alex, that we'll do next. I'm going to draw this out while people write for me the margin of error. So when you think about the margin of error is what the length of the interval. So people might be figuring out this interval goes from here to all the way up here. And the margin of error is what the length of the interval. So if you think about this interval right now, this interval has a length of 7. So the full length of this interval right now is 7%. So the margin of error right now is plus, well, that looks like, that should work, plus 3.5% and minus 3.5%. So let's do this as a much, much easier problem. Let's say your friend says, I'll buy your GameCube for somewhere between $40 to $60. They're going to buy your Nintendo GameCube. They'll say, I'll give you about $40 to $60 for it. What is the margin of error for this interval? They say, I'll give you $40 to $60 for your Nintendo GameCube. I like Nintendo GameCube. They say, I'll give you $40 to $60 for your Nintendo GameCube. What is the margin of error right here for this interval? Adding this together twice. That was the full length of the interval. Great question right there, Kyle. Plus or minus 10. Remember, it's half the length of the interval. Half the length. So always check your margin of error by writing it this way. 50 plus 10, 50 minus 10. Does that make sense that this is now the margin of error right here? The margin of error is going to be 50 plus or minus 10, and the margin of error is half the length of the interval. No one sells a GameCube with them. I think I got 2 GameCubes. I might have a third. Got the black GameCube. I think I have a purple one too, or indigo is the actual color. There's a lot of good GameCube, and then Spice is the orange one. So like the names of the Nintendo black, orange, and purple, but they had like special names. It is such, man, GameCube is such a great, you know what? Do I have it on here still? I got some Mega Man music, some Nintendo right there. Vintage, right? GameCube came out when I was in college. Enough of Brian being old. Brian's old. We got here Bright Hen. You still got this. Who's going to win right here? Let's find out. Quiz. Find the standard deviation. This is a tough one. P times Q over N square root. P times Q over N square root. Oh, Super Smash, you bet. Mains are Pikachu and Samus. What are your mains? Put your mains in the chat right now. P times Q over N square root. Game Boy's great. Gotta love some Game Boy. Some DS. Some, is DS right now dual screen? Then 3DS came out. It's 3DS, right? But then Switch took over, so. Captain Falcon. No, wait, Falcon, right? Captain Falcon, because then there's Falco. So, but Falco's from Star Fox. So, Captain Falcon. Falco Punch! He just knocks you right off the ledge. Man, Kirby? Yeah, Kirby's great for, like, just, like, going whoop, 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 whoop. And then he just smash these down smasher things and, like, cancel out the smash midair. Mario, no doubt. Ness. Ooh, we got some PK Thunder, PK Lightning, PK everything. Zelda just, man, Zelda like boomerang in the air. Mario Kart. I love some Mario Kart. We're talking video games right now. Buffer, hopefully we're back. I'm sorry, so sorry, Campbell. It might have just been you. I'm hoping. Oh no! There's this answer right here. What did people use if they have this? Sephiroth? Oh, Sephiroth so isn't he the newest one, Barrett? Didn't Sephiroth just get released end of last year for Smash Ultimate, Brawl, oh my gosh. Why am I getting Smash wrong? He just got released though, right? People used P hat here. Make sure to use P here. Zero Suit Samus, Wii Fit character. I've heard Wii Fit character is actually pretty good. Was it that dude from Kirby or whatever? People played against me and they destroyed me with that. I'm not bad at the new Smash. The new Smash is just not fair. That's all I got to say about that. It's controller latency. That's what it is. Yeah, I noticed that. I saw that, Bear, and I haven't gotten the new one yet. Well, I have the new one. I just haven't gotten, I don't have the updates and stuff, and I'm still doing World of Light stuff. And I just feel like the game just like goes up, like it just destroys you sometimes. I don't understand all the cards. I'm just like, I don't get this. So this uses King DDD. Yeah, that's who. One of my friends played against me with him, and he was just wrecking me, and I was like, I feel like I'm bad at video games. I don't like that because I swear I'm good at video games. So P times Q over N square root. Right here's the equation. P times Q. Don't use P hat and Q hat. That's a very common error. Make sure this is p times q over n square root. Ending off here with some video game talk. Give me talking about video games. There's no end to it. So, yeah, I'll have to... I bet Sephiroth sounds like a cool character. I mean, just like, he's got one of the best themes from Final Fantasy VII ever. So gotta check out new Final Fantasy VII and stuff. With this, let's check out the next question. Let's find out who's going to win. This is insanity, everyone. This is one of the closest games I've ever seen. Standard deviation uses p times q over n square root. And that's for the standard deviation for the sampling distribution of the sample proportion. Is there latency on the test, Kyle? Is there latency? You swear it's just like, it's the latency on the test. I feel it, man. For the sampling distribution of the sample proportion, what is the third condition? Condition 1 is random. Condition 2 is 10%. And the third condition is what? For the sampling distribution of the sample proportion. Campbell, you are correct, and that's for confidence intervals. Campbell is correct with what you put in the chat there. That is for confidence intervals. So for confidence intervals, it's p hat times q hat over n square root. And the third condition right here will always change depending on what we are doing. So the first condition is always random. The first condition is always random. Next condition is 10%. What does 10% mean? A lot of people get this wrong. We put some simple questions on the test sometimes regarding it. What does the 10% condition mean? What does, just like waka, Pac-Man. What does the less than 10%, well, that's the answer to it. What does it mean more so than that, which that's what the second condition is, which is a weird, confusing one because you're like, I think sampling more is better, and you are right. At most, we cannot sample more than 10% of the population. So is sampling 80 UTK students going to violate the 10% condition? Is sampling 80 UTK students going to violate the 10% condition? Is that going to violate sampling 80? It would not. Because sampling 80 UTK students is less than 10% of all UTK students. Does that make sense? Sampling 80 students is less than 10% of all UTK students. Great practice right there. And good to see everyone in Karina and Audrey and Elish. How about, would we pass the success failure condition for, let's see, we got some example problems up. Would we pass the success failure condition? I'll write an example problem. You ready? We know that 20% of UT students are from, I was going to say North Carolina. Sure, why not? Oh, then we'll go lower. I just want to make this problem halfway reasonable. We sampled 200 students and want to see if we see the proportion we find. Draw the sampling distribution. First off, we randomly sample. Do we meet the three conditions right here for this? Condition 1, random. We randomly sample, exactly, Devin, you are correct. We randomly sample students, and thus we meet the first condition. 200 students is less than 10% of all UTK students. And people, Ella, great job right there, is already checking the success failure condition, which the success failure condition is going to be NP has to be greater than or equal to 10, and NQ is greater than or equal to 10. And if we meet these conditions right here, and let's substitute in the mathematics. So with this right here, NP is 200 times 0.06, and 200 times 0.94. And this right here should be 12. And you'll notice both of these added up equal up to 200. So notice when you solve for NP and NQ, you get the total sample size. So this passes because they're both greater than or equal to 10. Great job, Crystal, right there. This passes because they're both greater than or equal to 10. Thank you so much, everyone, for the participation tonight. Practice like this is what we need to be able to work the problems and make sure to get it down. Let's take a second right here and see if you can solve for the mean and standard deviation of this distribution. What would the mean and the standard deviation be? Well, who knows what the mean of this distribution is going to be? So what is the mean for the distribution of the sample proportion going to be? So what is the mean for the distribution of the sample proportion going to be? So we're marking our notation, always a good thing to do. Exactly, it's P, because we know 6%. So the mean is going to go right in here at the center of it. And we're going to go right here and we're going to put 6% at the center. And then we need the standard deviation, which, who's figured out the standard deviation for this already? We need to do P times Q over N square root. So P times Q over N square root. And so we're going to plug in the numbers. P was 0.06, Q was 0.94. over n 200 square root and 1.7%. Nice job, Abigail. Excellent work. And Devin and Abigail, great job. Yep, Haley, you got it. P times Q over n square root. I'm going to write it in so people can see if they didn't have it, but it's also in the chat with the answer. I'm just going to do that over it. And so, oh gosh, we got to go to small pen. Okay, let's try this. 0.06 times 0.94 over 200. And that was the answer right there for that. And then you can go and draw this out right here. You know what we're going to do? We're going to go to the David M. Lane, and we can see the David M. Lane for this. So let's go look at David M. Lane, and let's go put that number into here and see what the sampling distribution looks like. Mubot, where are you at, Mubot? Let's listen to some more music. Punch-Out music here. Classic Nintendo game, Little Mike. So from Punch-Out, here we go with the mean and the standard deviation. There we go. This is the sampling distribution of the sample proportion and shows us what would be likely or unlikely to see. And this just does all the work for us by putting in the standard deviations up and the standard deviations down. So with that, let's hop back here to the quiz and check out the last few questions. Fabulous Penguin. Amazing job. That is, I want to see a Fabulous Penguin. That's just a cool name. I like it. Just rocketing to the lead. It's anyone's game. Be quick. Brian, are you going live? Going to give us the confidence interval Z-scores for the test? You bet, Avery. We will definitely do that for you. Let's find out. Where's my Tech Mobile players? Oh, that's some good stuff right there, Kyle. You know some classic games. That is such a great classic game. Who's going to win? 2 more questions. What % of time did you get exactly 2 heads? So if you notice right here, we've got 0 through 4 is heads, and tails is 5 through 9. Scary music again. So you have to look at this and decode it. So wait a minute. We have heads, 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 tails, heads. So we got 4 heads here. Next, we have tails, tails, heads, tails, heads. Wait a minute. We got, oh, look at that. Exactly 2 heads. In this simulation right here, we got exactly 2 heads. So let's look at the next one. We have here tails, heads, tails, heads, heads. And I'm using this over here to tell me when it's a heads or tails via the rules of the simulation. Next, we have tails, heads, tails, heads, heads. Next, we have tails, tails, tails. Oh, heads, 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 heads. Oh my gosh. Got to get the simulation right? As long as I did it correctly, I'd write underneath this. If I could write underneath this right now, I would. We're talking some Nintendo Entertainment System, some Famicom in Japan, Family Home Console. Got some classic video game stuff right here. Nintendo playing card company from 1800s. They've been around a long time. Great job on this question. Make sure you mark down which ones are heads and which ones are tails. You'll notice right here exactly 2 heads only occurred in 1 of the 5 simulations. So 1 out of the 5 simulations, or 20% of the simulations. Bo knows basketball. This man, PJ knows some 90s commercials right here. We're going 90s and 80s. It's just a 90s and 80s night. You know what? In honor of 90s and 80s night, we're bringing back on some 80s music. Let's do this 80s music here. 80s music to end this off. Turn up the 80s music. Let's go to the next question with the leaderboard. Here we go. What % of time did you get exactly 2 tails? Exactly 2 tails. Exactly. Not at least 2 tails. Please don't break Kahoot. Oh, I was like, oh gosh, the Kahoot breaks on this. Sounds like Pick on Me. Exactly 2 tails. So we need to look here that you get exactly 2 tails. Remember right here, you get heads, 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 tails, heads. It's not exactly 2 tails. Right here, we see you get tails, tails, heads, tails, heads. Not exactly 2 tails. Right here, you get tails, and we're just doing by the simulation numbers. Tails, heads, tails, heads, heads. Wait a minute. That's exactly 2 tails. Right over here, you get tails, heads, tails, heads, heads. Okay, that's exactly 2 tails in this, 2 tails. And then here you get heads, heads, heads. So it looks to me like 2 out of the 5 of the simulations. 2 out of the 5 simulations. We're having a special guest announcing the winner. 2 out of the 5 simulations right here. Yes, great job. You know what? It's time for the winner. We're bringing back some 80s music again here. Oh gosh. No, we gotta go. Let's go 80s classic. No. Here we go.
Hey everybody, it's Tiny Brian here for the winners. Got my 80s music. Let's do this. Here we go. Third place is gonna be Clever Lemur. Great job, Clever Lemur. Tiny Brian. Yellow Dragon, you were there the whole time. And winning $50 Amazon gift card is Helpful Jaguar. You can't beat a Helpful Jaguar. Great job, everybody. Hey, what's up, Pierce, right there? I'm Tiny Brian, and I want to thank you for playing this Kahoot. Back to you, Brian. I can't disappear, Brian. You're not, like, reappearing. Wait a minute, here I go.
Awesome work, everybody. I thought I had the voice tuner still on. No, that's Tiny Brian's real. Tiny Brian exists. Nice job, Lauren. Great job. Great game. Thank you, Devin, for all the positivity right there. Let's throw out some 200 points. I need to switch over to OBS for those who know about streaming. I use Streamlabs OBS. I need to fix it. Great Kahoot tonight, everybody. There'll definitely be some more practice. We're going to be reviewing for all of our classes. You're welcome, Tori. If you got in first, second, or third place, please email me. Email me with the, you're welcome, Sarah. Great work tonight. Feel slightly more prepared. That's exactly what we want. 90 minutes of great review with great questions. Use Streamlabs as well. Pierce, email me about this. Like, my background right here, this background, let's like destroy the background. Where's my background on this? It's not 80s background. We'll put on some more music. We'll put on some chill music. Let me reset this background. I've got this background. Where's my background? Is it this? There we go. No background. It stalls, and I don't know why. Have fun watching Netflix. Like, I don't know why the background. It's probably because I've got like gigs of stuff loaded in. But you see, it breaks. It breaks, and I don't know why. You know what we could do? Wonder if the world news one is working properly. Maybe I shouldn't have, a bunch of large video files loaded in all at one time. Maybe I kind of know the issue and just don't want to acknowledge the issue of having multiple files. Time to study anthropology. Good luck with studying anthropology. That doesn't work right now. I'd have to rearrange this. It doesn't work with my space theme, but I'm just switching around layers right now, and I don't know why that. Might be because you're running multiple. Yeah, this is a really good computer. It's an NZXT computer, Pierce. It's got a TI 1080. So I would think it could handle it, but apparently not. You're welcome, Caitlin. Great job. Are we going over Canvas content quiz 7 during office hours tomorrow? Yeah, we could do that. Let's do that. We could do that. Like, let's put out a video on that because I think that one is due tomorrow night, right? So let's put out a review of that. You have an NZXT? That's awesome. Yeah, I really like NZXT machines. I've been very, very happy with this machine. So it was really cool that Haslam was like, we got it like specially approved or everything. RTX 3070, Ryze 5 5600X. So that's the video card, right? The RTX 3070, and then the Ryze 5 600 is that. Thank you, I've gone the first time. Awesome. We'll definitely do that, Tori. So stay tuned. We'll do that during office hours tomorrow. Remind me, jump to office hours and be like, we got this. The only thing I'm missing here is a decent hard drive, video card, and CPU. Yep. I'm trying to remember what my CPU is on this. They're good streaming machines, and they don't charge you crazy amounts. So Tuesday's class is just gonna be straight review. Yep. Student guided review on Tuesday. Student guided review. What do you stream on, Pierce? If you want to mention your streamer channel, I'm gonna drop the. I think I've still got the playlist. I don't have a playlist anymore. Let me go grab the playlist. Because you said you use Streamlabs, so I'm assuming you stream. I'm assuming we'll put on some more music. Throw me some streamer tips. I'm assuming you got a stream deck and all that stuff. Because if you're running the NZXT, you probably got a streamer deck. You're welcome, Devin. So glad to hear that. I'm really glad to hear people are feeling more confident. Twitch streams sometimes I game. What do you game? What games are you playing? Whoa. A dude I watch has a bunch of people streaming right now. What is your favorite game? Right now, my favorite games are Hades. We just finished Valorant. Yeah, I've heard Valorant's really good. Valorant looks like an arena game. I think Valorant I'd like to play. Looks like a lot of fun. I really wanted to I thought about Overwatch for a little bit. And PUBG, Overwatch. I looked at those and was like, those look fun. And I didn't play them. Fortnite. I watched some people play Fortnite, but I just feared I'd never be good at the building aspect. Because I watched Ninja play some Fortnite. And dude would like spin it around in a circle, and he'd have like a whole house built around him. He'd just be like, wah, 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 and then he'd have a house built, and I'd be like, got some CSGO, Counter-Strike, Global Offensive. I think that's what it's abbreviated for. CSGO's classic. CSGO's been around forever. Like, good stuff right there with CSGO. Oh, Overwatch, divided by CU. We still have class tomorrow. Yep. Be reviewing speedrun reviews in the chat right now. Try Apex. Yeah, Apex. Actually, I did do a little Apex. I was doing like I did a few rounds of Apex. I didn't do horrible, but I think I accidentally like dropped some grenades near my team a few times. The guy's like, throw a grenade. Oops, that hit a wall. I don't know how to throw grenades in this game. Because I was really good at a Transformers War on Cybertron game. I really like that game. Like, I just haven't played many arena or team co-op games like that many times online lately, like the last 5-6 years. So, yeah, Ninja's just, the way he just builds, like, you're like insane, dude. It's just like, he just spins around. He's got this full shelter, and then he's just like mixed the whole, and he's just like, I'm like, how do you even do that? Just amazes me. I like Binding of Isaac, Hades, Enter the Gungeon. I like roguelites, I think they're called. So have a great night, PJ. A friend told me I should play Hades, and then I eventually checked it out, and I was like, yeah, I like Hades. Hades is an amazing game. So I think what else? Slay the Spire. That was a great game. You can't, yeah, exactly. It's some of those games are just like, it's so hard. We'll play 2 more songs and we'll head off here. You're welcome, Crystal. Thank you for hanging out. This is just our last few moments here, just talking video games. Fun to talk some video games. We're probably going to start Last of Us. We just beat Until Dawn. Until Dawn, great story game. Really fun, kind of like watching a movie. So Until Dawn, a really great PlayStation 4 game. We got a PS5 and are playing the PS4 catalog. Beat God of War. God of War was stunning. Stunning and amazing story. Best movie I've seen in a long time. Until Dawn was great. Now I think we're starting Last of Us. Because Last of Us looks awesome. Like, Last of Us, and then we'll probably play Last of Us 2 eventually. I've heard Last of Us 2 is good, but Last of Us 1 is, like, the game to play. So, and then we've got Horizon Zero Dawn. So many Dawn games. What else? And then we have one more. Oh, Uncharted, because we didn't play much PlayStation. Awesome, Pierce. Anytime. We're going to head off after this song. But keep streaming. Keep having fun, everyone. If you have questions, let me know. Check out those speedruns in the chat. Mewbot, we're heading off here, Mewbot. We got our bot on YouTube, Mewbot. You want to say anything, Mewbot?
I am Mewbot.
Let's say hey to Mewbot and leave. We got this. Mewbot, thank you for what you do, Mewbot. And thank you, everyone else, for being here. With that, keep preparing for the test. Study up. Check out the speedrun videos in the chat. We'll put some labels in this video, and we'll head off here. No, I like that, Elish, right there. Keep winning. Keep getting more points. Here, wait. If you're still here, Elish, don't tell anyone. Oh, wait, Liam's still here, too. Let's do 200 points. There we go. Last bit of points. Bye for now, everyone. Bye.